Hi there. In this lesson, we're going to talk about a very important topic known as exception handling, or another term for that is error handling. And it does exactly what it sounds like. Let's say you have a user using your application or website or whatever, and they perform some kind of task, and all of a sudden there's some kind of error, okay? We'd like our application to ideally handle that error in a graceful manner, right? You don't want the user of your application to see a scary message that exposes the internal code of your application. That's really bad, right? Poorly designed websites go through this where, if there's an error that occurs, the internals get exposed to the user and they see this really long stack trace, almost like a log of all the errors that took place, and that's no good. You want to handle your errors gracefully, and errors or exceptions are a common thing in application development. All applications run through this. So we need to be able to handle these in a more graceful manner so that we don't scare the user away, okay? So what do I mean by that? Well, I have some code that's pasted here. Let me paste that code. And you should be familiar with what this is doing, but I'll just give you a quick summary. We're defining a function here, sum, and it accepts two numbers, and we're printing the sum of those two numbers, okay? Now, here's the thing. Notice number one, we have this variable, and that accepts input. Remember this input function? This takes input from the user of the application in the command line in the console. When we enter any number or word or whatever, that's what you use for input. That data that the user enters gets captured in this number one variable. That's what I titled it. And so now I'm passing in the number 12 as well as number 1 to the sum function. What's going to happen? Well, if you recall, the input function actually accepts everything as a string. So even if you enter a number, it's going to convert that number into a string representation and save it into the number 1. So when we use this function here, we're actually not using it correctly or the intended way. We're passing in a string and we're passing in a number, and you should know by now what happens when you try to add a number to a string. We should get a type error, and I've shown you this before, right? So let's run this and see what exception occurs. Let's run it. It's saying enter a number, so let's enter the number 10, and boom, we get an error. Notice type error. Can only concatenate string, not int to string, okay? And as you can see, process finished with exit code 1. So anytime the exit code is anything other than 0, that means there's an error that happens. There's an exception, right? So this is the error, okay? Or the exception, same thing. So rather than displaying this to the user of the application where it tells you, hey, in this file, at this line number, this particular function exists and it did this, you don't want that. You want to handle this in a more graceful manner. So how could we do that? So in Python, and all programming languages have the ability to do exception handling, there's a specific syntax, okay, that you use. And that is known as the try except syntax. So the way it works is we use the term try, we use the keyword try here, and this is a code block. And after try, there is except. You put a colon, and then the code that you type here will run if there's an error in this try block. I'll explain to you. Let's run, let me type, there was an error, okay? And that's it. Let's just say that that's the only thing we want the user to be able to see. We don't want the user to see this nasty message here that exposes the internals of our application. So now, if we run this, again, this is what the method or function is supposed to do, right? In the try block are the instructions of what the function is supposed to do, right? But if there's an error anywhere in this try block, then this happens, which is the except section. So we know that there's going to be an error, but we also know that now it's going to be handled gracefully. Let's run this application. Enter the number, let's just enter 10 again, hit enter, and boom, there you go. Notice it says there was an error. And so when that happens, we can move on to bigger and better things in the code, right? We can have a very large set of instructions here, really a very massive program, but it won't crash because we're handling the exception. When you actually don't handle an exception and a crash occurs, your program ends. That's it. It's over. But with this try except block, you can actually handle exceptions and prevent your program from completely crashing. Now, there are some practical software design principles that you should follow when you use exception handling. Exception handling or error handling should be used only when there's an error that happens that you really have no control over, that could happen, right? That you won't expect. For example, let's say your software relies on the internet and goes and downloads files from the internet, for example, right? Now, if a user is running your program, but they run it with no internet access, that could cause a crash. Now, of course, if you're a good software developer, you'll code for that type of scenario, and you're not going to throw a dirty error on the screen showing that this file was attempted to download from this such and such website. So in that kind of a situation, you should be using exception handling. Another scenario is, for example, your program relies on a file to be to exist on the file system. It reads some kind of file with a given name or whatever, and let's say that file for some reason got deleted. And when the user tries to run the program, of course, is going to look for that file, and if it's not there, it's going to crash if you don't have exception handling in place. Okay, so it's for situations like that, where it's environment-dependent situations that could happen, but you don't expect them to happen. You want to make sure you use exception handling to cover those types of scenarios. Now, in this simple scenario, we don't really need a try and except section. Because, for example, let's say the user enters number 1 and number 2, and one of them is a string. We can check for the data type of each of these parameters that are passed to the sum function, and if any of them are not a number, we can just print to the user and say, hey, listen, you need to be giving only numbers to this function, okay, rather than letting it crash. And for that type of scenario, you do not need a try and except. For that, you can just have an if statement to check the data type of each of these. And if they suffice, then the function will run correctly. If they don't suffice, you can have an else clause that says, hey, enter the proper data type for this function. Try except is used for situations that are kind of out of your control. Enforcing the data types of num1 and num2 to be int is certainly totally in our control. So we don't need exception handling here, okay? So we can get rid of this and use a different kind of way in which we can make sure that the function is used properly. So you can probably already guess that we're going to need to check for the data types for each of the parameters. There is a function known as the type function, which we've already looked at for sure. There's another one that could be used in if-else statements, and that is known as isInstance. So let me use that one. So if we do if isInstance, num1 is of data type int, and isInstance, we do the same thing for the other parameter, num2, and we say if that is of type int, then we're going to print num1 plus num2. Else, we can notify the user and say, hey, data type was not a number for the parameters. And this should work perfectly fine. And notice we're able to handle this issue without using exception handling. And so when you can do that, make sure you handle the issue without exception handling. Don't just put exception handling everywhere. Things that are in your control, you should certainly write the code and the logic to handle those kinds of scenarios like we're doing right here. We did not need exception handling in this situation. There's an important point. I'm going to repeat myself. Things that are out of your control, only for that you use exception handling. Things like not being able to connect to the internet while your application is running, the disk running out of space on the machine, or a file getting too large for your program to handle, things like that. Those cases, for that, you should have exception handling in place. And what is exception handling? That's the try except block that we looked at, right? You try a piece of code. If there's some kind of error that pops up, then it jumps to the except block, and it does what the except block is doing, right? So we're going to look at a practical scenario in the next lesson where we actually try to open a file, okay? And I'm going to show you how to read and write files, and we're going to explore the scenarios in which, the file gets deleted from the system, and so we're going to handle for those types of exceptions. And you're going to see this in practice, the practical implication of this. So stay tuned. I'm going to see you in the next lecture. Thanks for watching.